All right. So, hi everyone. Welcome to the mechanical design panel. In this panel, we're going to be discussing the different strategies that our teams use to ensure that we come out of build season with a competition-ready robot. So, a little bit about the structure of this panel. We're going to be starting by doing some introductions and talking about our basic design strategies for each of our teams. And then we're going to proceed into a Q&A session. So because this is a panel, the majority of our time is going to be spent on the Q&A session. So I have some questions prepared here, but if you have any questions, please feel free to throw them in the chat, and we'll do our best to get to those. But yeah, please ask any questions that you have in the chat. So yeah, to start off, I'm Helena. I'm a junior on team 1678 on the design sub-team, and I'm going to be the moderator.
So my name is Alex Burkhart. I'm the design head on Team 701. I'm also pretty involved in the mechanical committee, and this is my third year in FRC.
Okay. Hi, I'm Maya. I'm the head of manufacturing on Team 701, and I'm also a member of the mechanical committee, and this is my third year in FRC. So in our shop, we're fortunate enough to have a lot of machines that we use to make custom parts, such as a Haas CNC TM2P, which we use for a lot of our larger parts and especially our tubing. And we use a mini mill for our plates, especially our gearboxes. And we have a shop bot, which we use to cut out a lot of our acrylic and wood parts, which is really helpful during prototyping, and a lot of 3D printers. So information is relayed from the design committee to manufacturing through Google Forms, which the designers use to input part information so that the CNC programmers can use that to make the parts and figure out which part file they need to import into Fusion 360 to do the CAM. And then afterwards, they use a physical work order form to give information to the machinist so that they can cut out the right stock dimensions and upload the correct program number into the machines to run the correct parts.
We also have a couple documents that make sure that all design and manufactured parts are consistently, they're consistent, even if they're done by different people with different levels of skill.
Hi, my name is Lydia Walsh. I'm from Team 1481. I'm the mechanical lead, the human player, and this is my fourth year in FIRST Robotics. So on 1481, we have a number of things to help have our design basics. One thing that we focus on is our weekly design review, which we have every Saturday of build season and competition season. And all members of our team attend, no matter what sub-team you're on, whether you're a student or a mentor. And everyone attends it and basically communicates what they've been working on that week. So all of the design sub-teams talk about how each of their designs are going, and electrical talks about how their programming is going. And so this is able to communicate plans and designs to everyone, and also allows a period of questions to be asked. So then if anybody has any extra ideas or any other questions regarding what's happening, they can share those. In terms of tracking our progress and completion of things throughout the season, we use a Gantt chart style, which allows us to see in one big area how progress is going on each progress side by side. Our design process allows all of our students to be a part of it. So both fabrication and electrical students are a part of our design process. So then every single sub-team that's going to be working on the robot will get that input into the design, and allow for a more cohesive structure of the robot overall.
Hi, I'm Zach. I'm a junior on 1678. This is my third year on the team, and I am on our design team, and I am our human player.
And my name is Nathan McAllister. I'm the team's design lead, robot operator. I'm a senior in high school, and this is my fourth year on the team.
So the way that our team approaches design during the build season, we start off with prototyping. Once our team has decided what we're going to do with this game and how we're going to do it, potential ways that we're going to do it, we split off into prototyping teams that consist of all of our hardware teams. That's our electrical sub-team, our fabrication sub-team, and our design sub-team. This process lasts anywhere from 1 week to even 3 or 4 weeks. For example, with last year, our control panel mechanism, it didn't take too long to prototype and decide how we were going to approach it. So that one only took around 1 week, while our Wheel of Doom indexer system took a few weeks to decide exactly what we were doing with it. During this time, there are also 2 or 3 core designers who are working on the robot layout, like where mechanisms are going to go. And so then once prototyping teams are done prototyping, when they're kind of got their concept ready, they communicate this with the design sub-team. Each mechanism gets a designer, and most of this design is done at home, so that then we can work most efficiently when we're in the shop. We can work so that we can be doing assembly and iterating while in the shop, because design can be mostly done at home for our team. We work with our fabrication sub-team using our parts tracking sheet, which we can bring up in a second. This sheet basically it categorizes parts by their assembly that we're putting them in, and by their quantity and availability / their status. This is a way that we communicate to fabrication what parts need to be done, and then we make part drawings with dimensions of the parts, which and quantities, which detail how those parts are going to be made. So that's kind of the way that we hand off our process, our design process, off to the fabrication sub-team. So then they begin to make the parts. It allows us to get the parts back as efficiently and quickly as possible, so that then we can work on assembly and iteration and get as many iterations of mechanisms as possible, as quickly as possible.
We should be able to pull up the screen share now. Awesome. So this is actually, we just published this on Chief Delphi as well. I'll link that into the YouTube chat in a few minutes here. But this is kind of what our parts tracking sheet looks like. You'll see our name and convention on the left here, labeled by assembly in the first 2 numbers and part number in the second 2 numbers. And this is just a list of all the parts. It specifies the designer, which machine the part is going on. And we have these drop-down menus for status. So every part will start as design in progress as soon as we get into Onshape. And then as it proceeds through the process of needing a drawing or going to the lathe or whatever machine is going on, we just change the status so that everyone is on the same page. And then obviously this is our 2020 parts tracking sheet, so most of these are marked complete. But when you have this many parts, it is very convenient to not have to rely on verbal communication for this type of stuff. That would be a nightmare. Otherwise, instead, we just use the spreadsheet. It's very clear, and it's really just communication between the design lead and the fabrication lead on, if parts need to be remade or whatever. But this is a great solution that we found and published publicly just a few days ago on Chief Delphi. So I think we can jump to questions now. Is Helena disconnected? All right. I guess I'll just ask questions then, if everyone's okay with that. The first question that we had lined up was what software, both both CAD software and CAM software, does your team use in your design process? And we'll start with 7-1.
So we use Onshape, and this is actually a pretty recent switch for us because we used Inventor up until actually last year was our first year using it on the robot. Yeah, and we switched to it because it fit our workflow, the top down designing, and I don't know, Maya, you want to talk about Fusion?
Yeah, so to do the cam for our parts, we use Fusion 360. We have an online server, which is really helpful to put files for the parts in there and easily access them to import into Fusion 360. And yeah.
I didn't talk about 1481. For us, for our CAD and CAM, we use Inventor, and we found that it works really well for us. One, because Autodesk happens to be one of our sponsors, and using their Vault program, we're able to transfer the information and all of the files really easily throughout all of our computers that we do CAD on. So then we can share those more easily between the team and have them saved in a central location so they don't get lost or anything.
Great,
Yeah,
thank
on
you.
1678, okay. On our team, we use Onshape because it's kind of it's a little bit friendlier for a group work setting. It works better for our whole design team since we try to have as many people working on the same robot all at once, and because it's able to save things to the cloud. It's a little bit. I think we switched over from SolidWorks a few years ago, and we've found that it's just a little bit better for group settings than SolidWorks is.
And then for CAM,
Great,
we've
thank
always
you.
just used. Sorry, for CAM, we've always just used Cut2D Pro, just because it's what our main fabrication mentor is comfortable with, and we don't really need anything more than 2D profiles for our routers at the moment. So we've just been sticking with that.
Great, thank you guys. It looks like we have a question in the chat. So I'm gonna read it, and if any of you guys wants to answer, that'd be great. So it says, do you use Step to go from Onshape to Fusion 360? Have you come across any difficulties with revising parts? For example, recamming the entire part or camming a down rev part?
Oh, sorry. There's not really any difficulties from importing step files into Fusion 360. If we do have to revise a part, we just redo the whole entire cam and import the new file in. And since we use our standard templates, it makes the cam for those parts really quick and easy. So there's not a lot of time spent doing the cam. So it's not too bad.
Great. Okay, so our next question is, how do each of your teams incorporate 3D printing into your design? And do you have any tips or tricks, I don't know, with respect to that? So we'll start with Zach.
Yeah, so we basically try to add in 3D printed parts wherever I guess it would be too complicated to add in other parts. But for things such as like electrical mounts, we like to use them for those. We don't generally use them for anything that takes too heavy of a load. Except when we do, we are fortunate to have Mark Forged printers, which put carbon fiber reinforcement on the parts. But we mostly implement them in the form of mounts and anything else that would be too difficult, I guess, to router out or to mill out, or anything that's just in weird shapes in general.
Great, thank you. Lydia, do you have anything to add to that?
Yeah, I'd say ours is pretty similar. We haven't actually used 3D printing much into our final robot designs yet. We actually just started doing that last year, where we made a bracket for a sensor, a Hall effect sensor, to go on our robot. Most of the time we just use our 3D printer as more of like experimental / prototyping. And then we wind up making most of our sensor brackets if they're not included when we get them.
And then Alex for Team 701.
Oh, so we try to not use 3D printers unless it's for things that will have almost no load, like sensor mounts, and that was because we kind of had a kind of a rough time with 3D printers a couple years ago. So we try and stay away from those if we can.
Great, thank you for all your insight, guys. Looks like we have another question in the chat. I guess for the teams using Onshape, do you have any regrets regarding the move to Onshape? And do you feel the Onshape command feature set is doing the job for you? So Zach or Nathan, if one of you wanted to start.
Yeah, Nathan, do you think you can take this one?
Yeah, I can speak on this. So, our main concern with Onshape was kind of that it was a little new when we moved, right? It doesn't have all the really niche features that SolidWorks might have. Like for example, assembly mirror is one of them that's a little bit annoying to work around at times. But we've gotten really used to how Onshape works. We had concerns about the mate connectors, but they ended up being great. We love how they work. It's just a few clicks and everything's in the right place. Unlike SolidWorks where you have to mate, 2 or 3 times to get everything in the right place. And in terms of our needs, it really just fits better because we do most of our design remotely. It's really awesome to be able to include more people than just one person at a time in the design software. And so, like, I could be on a call with Zach, right, working on a mechanism. He's looking at my screen through Onshape. They have this feature, you double click on the other person's name in the top right corner, and you can just follow along with what they're doing. And it's super cool because it just allows for a lot easier communication. Our mentor, Mike, you can go in at any time and see the updated version, most recent version of a robot, make any suggestions. So yeah, I think the feature set really fits our needs nicely. Obviously, it won't be like that for everyone, but it really worked out well for us.
Thank you, Nathan. Does anyone else have anything to add to that? If not, we'll move on to the next question in the chat. Okay, in the chat, it says, can 701 share their standard Fusion 360 CAM templates?
I'm sure it's possible. I could give you my Vanda Robotics email. It would just be mayaS@vandarobotics.com, all lowercase, and I can share the template with you. But essentially, it's just a bunch of standard speeds and feeds that we found have worked with our machines and our tools, and all of the passings and tolerances that just work for us. But I'd love to share with you if you could email me.
Great. So our next question is, how does your team go about making decisions regarding mechanism types? Is it a whole team decision, or like who has input regarding those decisions? And when during the design process do those decisions get made? So I think we'll go first to Lydia.
For us, it really kind of depends on the subsystem, but usually the decisions are made by members of our individual design teams that run our subsystems. But for, let's say, our chassis, that would be more of a whole design team decision, and we try to pick that out the day one after kickoff. So then we can get that going and get that already being designed in our CAD. For most other systems, we have a library system where we've have a lot of inspiration and different mechanisms that we've used and found that worked. And so usually the design teams at least take a week to go through and see what's going to work. And we use things called pixie charts. They're basically a pros and cons chart. And by using those, we are able to like decide what's the best way to do whatever challenge we've been given and how each mechanism can work to our favor or against us in those situations.
Really interesting.
For
Thank
16th,
you.
do you want me to talk about it too? Or sorry. Okay. Yeah, for our team, on kickoff, our whole team comes together and we basically talk about what we want to do first, which task we want to accomplish. And then on the second day, we talk about how. We bring up some like design possibilities, basically. And then this goes into our prototyping decisions, into what prototyping groups we decide to make. We decide what kind of thing they want to try out. And then based off of how the prototypes that those groups make, how well they work, then our design team kind of just decides from there on what which mechanisms are going through for each different category, I guess.
Yeah, it really is worth noting that the prototyping teams are there to figure out geometry, right? We're there to figure out, do we need a top roller on our sheeter? Do we need multiple intake rollers? That sort of thing, right? And where should those be positioned? And then once you have that, it's just a copy paste over in CAD, and the design team is really working on how to integrate everything, how to fit everything together. And so, a lot of that falls on the core designers who are working on some of the bigger mechanisms to communicate a lot about that. And also, obviously, with mentors, there's a lot of knowledge there that we can use as well. So.
Does someone from 701 want to speak about that process for their team?
So our team, we usually start deciding these kind of things in the first couple of days of the season. So we talk about like what the pros and cons are as a team, and everyone's involved, and no one really has any more weight than anyone else because the more you talk about it, the more ideas there's going to be.
All right. So kind of going off of that last question, how is your mechanical or fabrication? How are your mechanical or fabrication students part of making those? Like, are they part of making those decisions? And if they are, to what extent and at what time during the season does that kind of input happen? So I guess we'll start with Maya.
Yeah, so as Alex said, everyone's involved in prototyping, but there's a separation of jobs between design and our manufacturing groups, and a majority of the machinists that operate the machines are actually from our mechanical committee, so they aren't really involved in designing the parts, but everyone still has a role in prototyping.
What about for Team 1481, Lydia?
For our team, our design and mechanical team are pretty fluid in terms of like what students are on each team. We only have a few students on each team that are like, oh, I'm only going to do CAD or I'm only going to be fabricating. So usually our fabrication students are also the design students who are actively designing the parts and systems. So there isn't really much of a separation. But they do usually try to at least talk to the people who are mainly design people and see, oh, how are these going to mesh together within the robot, and have a lot of conversations about packaging and timeframes for design.
And then Zach, did you want to speak about that?
Yeah. For our fabrication involvement in prototyping is pretty similar to 701's, where basically our fabrication students and our electrical students and design students are all in those prototyping groups together. In fact, actually, we have a prototyping lead on each team, and we normally have a few fabrication students be the leads of those about 6 prototyping groups per year. And then once prototyping groups have kind of come to a conclusion on what the mechanism is going to be like, then they start to split off into their own jobs. Designers will start working on the CADing of the mechanism, and then fabrication students will be working on making parts and helping with assembly. And so will electrical students getting ready for wiring robots.
Great. So I think we'll move on to the next question. What does your build season design schedule look like? For example, how much time do you leave for iteration? How many iterations might you make on a mechanism? And how does accounting for that time influence your design or your design process? So can we start with Lydia?
Yeah. On 1481, we usually try to have our CAD done by week 3, and then our robot overall finished by week 4, but it usually winds up being week 5 when it's actually completed. But we usually try to have at least 2 iterations for everything. So then we're trying to make sure to test out new ideas and make sure that we're always improving on our current design of the robot. But beyond that, it really depends on the subsystem. For smaller subsystems, they either get done at the very beginning or get moved to sort of the end. So then they are on the back burner while we can focus on the more complex subsystems. Like for the 2020 game, our main forerunners that we were focusing on were our shooter and our climb system. So our color wheel selector wound up getting put on the back and still in design process, but there was less focus and less people focused on that. So then we could focus on the things that were going to take more time and require more people to actually design and then fabricate. And we usually have our prototyping period for all of this be in the first week and a half, 2 weeks. So then we still have enough time to actually input our CAD and then actually fabricate the final designs.
And then Zach, do you want to speak about that for 1678?
Yeah, so once our prototyping is done, we kind of start moving into the iteration process where designers will start designing out the mechanisms. And we're actually able to iterate really through the whole build season and competition season because of the fact that we make 3 different robots. We make one competition one, and then 2 additional robots so that we can be constantly cycling through, like having one robot in the shop getting iterated on, like getting new mechanism iterations put on, having one over for programming to work on autos, and then one over maybe for driver practice or for one of the 2 previous jobs. So that allows us to be iterating as much as possible throughout the whole season.
I'll add to
And then
that we really stress kind of push one robot out as fast as possible. And so we know this first robot that we kind of CAD out and detail out is not going to be our final one. And this is a really important step of our process. By week 4, we have a fully functioning robot. We put out our reveal video. That robot is nowhere near competition ready, but we've proved it's a proof of concept, and it's a really surefire way to make sure we catch anything that we didn't realize during prototyping, right? And so after we get that out, it's like a hairball. We just spit it out, right? And then we can move on and get to the better stuff in our competition robot.
great. And then Alex, did you want to talk about that?
I don't really have that much to add because a lot of our timeline is very similar to what people have already said. Our goal is usually around week 3 to be finished with our CAD, but in the past it varies a lot because it just depends on how well our prototyping went, how many iterations we need to do. It just depends on what the subsystem is. Our intake last year, we had 13 iterations, but I think our shooter only like 3 or 4. So it really just depends on what the subsystem is and how, I don't know, how much you need to tweak it.
Yeah, that definitely makes sense. So I know you all spoke about this a little bit in your intros, but maybe you could elaborate a little bit more on the communication devices that your teams use to get parts all the way from having no design at all to being incorporated in the robot, and maybe the process, like what maybe you used 5 years ago and that how that has evolved throughout the seasons to better suit your team's needs. Maybe we could start, Zach.
Yeah, so we, again, kind of our 2 major components that we use in getting our robot from design to fabrication and assembly is through that parts tracking sheet that Nathan showed earlier, and through part drawings. So pretty much our designers are able to convert the parts really into just numbering them off, so we have a good list of all of them, and then we're able to manage all of our part drawings, which are how we actually take the dimensions of those parts in CAD and turn them into something that can be machined, and something that has material listed and all that. And then after that point, it kind of goes back to a combination of the designer and the fabrication sub-team's assistants. The designer will normally coordinate the assembly of their subsystem, and then they'll have hardware members from all 3 of those sub-teams come together and help them assemble.
Yeah, and then on 1678, we have liked to print out all of our part drawings. So Onshape has a great part drawing tool. We just make the part drawings on there, and then we print them out. And we found that very effective. We could just print them out in the shop. We get paper from the school, no big deal. We hand them over to fabrication lead. He will distribute them, and we have just some big binders that we put in. We have a binder for parts to do and another binder for parts that are completed. So, and that way it's really easy to keep track of all the parts we do. And also each part drawing has a date on it. And so we can keep track of iterations that way. If we have to remake a part or something like that, it's really easy to know which one we made when.
And then Lydia?
Ours is actually pretty similar to that. We usually keep track of our parts through the part drawings. We don't have a sheet or anything to track the parts. That's usually done by the main design lead of whatever subsystem that is coordinating all of the process for each subsystem. But we use our parts tracking, not parts tracking, the parts drawings to be able to tell what parts have been made by marking off on the parts, and then the lead will usually keep those and keep track of what parts need to be made and what parts have already been made.
And then we'll go to you next, Maya.
Okay, so we use the Google Forms that I talked about earlier and the physical work order forms. I made copies of them so I can share them in the chat in a second. But pretty much our Google Forms is what the designers use to tell the manufacturers and the part programmers that there are new parts that need to have CAM be done. And what's really cool about Google Forms is that you can input all of the response into a Google Sheets. So that is what the CNC programmers look at to determine which parts need to be made. And we asked for like specifications such as the end location, or like what intake or subsystem it's a part of, and the date that it needs to be finished by. So we usually organize our sheets by the finish date because we want to put out the parts that are needed the soonest. And after, we have just normal tables that we made in Google Docs, and that is what the CNC programmer uses after they do the CAM for the part for the machinist to use. So that helps us separate the jobs and makes it really easy for there to be a smooth flow of production. So on those work order forms is what we call them, we ask the programmer to specify the stock dimensions, the program number, and any other relevant information like the end location that it should be put into. And we recently also started a system where we put in post work order forms because the coolant tends to mess with the paper, so it gets just really dirty and hard to read it. So we print out those, and the machinist will fill those out and keep them with the part in their end location. And yeah, I'll share those links in the chat.
Thanks, Maya. Okay, if no one else has anything to add, I think we'll move on to the next question, which is, how does your team start the design process? Like from the very beginning when you find out the game, or when you're working on an off-season project even, how do you start it? But like from before you have any CAD to maybe planning for CAD to prototyping, what does that look like for each of your teams? So let's start with Lydia.
1481, on the day we get the game on kickoff, what we usually wind up doing is everyone basically winds up sitting on the floor around a whiteboard or a piece of paper, and we just start throwing ideas out onto the list, and just if anybody has any idea on how to tackle this, what are your ideas, and just plop them out for everyone to see. In the following days, we then try to refine that, and as our strategy requirements come in, we definitely try to take what ideas we have and try to fit those into the strategy requirements. From that, we then usually split off into our designs, which are going to be the ones who design the main parts of the robot and also do the prototyping. And those teams then take what ideas that we've already had and then also expand on them by using our library system, which is just a collection of videos and other mechanisms that we've done as a team, and see what we've done that can actually fit into those ideas. From there, then we'll start to actually coordinate like an actual prototype that we will be attempting to see if it's going to work. From those prototypes, we also usually make additional pros and cons lists and see how things are going to work based on weight, difficulty, design complexity, that sort of thing. And once we have a prototype that's starting to like seem like it's going to work and fit into it, then we start making our CAD, basing it off of the prototype. But from there will definitely be a lot of different like design tweaks and ideas that still go into the process, but are still based around the central idea that we've already established.
And then we'll move on to you, Alex.
I don't really have that much to add again because there's our systems are very similar. Yeah.
Okay, and then Zach.
Yeah, we start off in a pretty similar way to what Lydia said, where our whole team kind of gathers around a whiteboard and we talk about what we're going to do and then how we're going to do it, which kind of starts us to throw out these design concepts. During this time, I guess over the first couple days, normally the design lead will make a Crayola sketch of the robot, the sketch that throws together the ideas that we have into something that feasibly works within the dimensions that we have. And then we work from there in deciding what mechanisms we want to try out, which then feeds into the prototyping process that I have described earlier. Yeah.
I can show off some of those Crayola models. That'll be valuable. Let's jump to the screen share. All right, awesome. So this is like day 4 or 5, just preliminary sketches. You might be a little surprised here. You see we modeled a tall bot to begin with. This is what we thought we were going to go for. It looks a lot like 973's final robot. The main issue here was the climber for us. So we talked through the hows. We didn't really see how we were going to fit a climber under the trench run. As soon as we came up with our folding design that went on our final robot, we were like, okay, we have no reason to go tall now. We know how we're going to package this. And so at that point, I threw together this quick model here. This is just a very, rough idea of how everything fit together. But you can see as soon as I throw into assembly, just grab a drivetrain. It doesn't have to be the one from the year you're working with. It can be a past drivetrain. Throw everything on it. And you can see this looks a lot like the final product of our robot. And this was, like halfway through week 2, maybe. And we pretty much knew exactly the direction we were going in from here. So it really is the design team's job. This is really how the full design gets started. It's just throwing things together, making sure your packaging is going to work based on what you find in your prototyping and what you feel confident in accomplishing. So.
Great, thank you. My next question is going to be, how does delegation look with respect to design on each of your teams? For example, how many people do you have designing each mechanism, or how many people do you have working on CAD for the robot in total? And and also just how many people are on your design sub team in general, and how does working together with other people look on your team? So I think we'll start with Alex.
Oh, he
Okay,
just
it
told
looks
me
like
that his
Alex.
power. Yeah. But I'd say we have about 5 people working on designing, and they're usually in charge of their own sub team and intake, or just subsystem in general. Yeah.
Okay, and then Lydia.
For ours, we usually have around the same number of design leads that are heading up each of their own subsystems. And then from there, we usually have those main people working on their CAD plus the addition of some of our CAD students and any other students that work on CAD. And they usually have specific students that are helping them on each of their projects. Like last year, I had one of actually the fellow design leads helping me with my CAD, just because it was a bit complicated. And yeah, it really just delegates down to a couple of people, because we don't have that large of a team that is working on the design.
And then Zach.
Nathan will probably give a more thorough response on delegation. So you want to cover that one?
Sure, I can take it. I mean, it's pretty straightforward. We do have a larger team than normal. The design team this year was about 15 students, and so it's quite hard to give equal work because of that. Obviously, we try to prioritize, the things that need to get done fast to the more experienced members, and it is we can delegate a lot of the smaller details, like the 3D printed parts for mounts or spacers or shafts or part drawings, toolpaths, that sort of thing. And it's really about getting new members kind of involved in the process to where they can pick up in following years. So that's kind of how the delegation works. We have some core designers that really figure out the details, the geometry of each mechanism, and then we can kind of tie the new members into that with more of the detail work.
Great, thank you. The next question is going to be, how do you prioritize different mechanisms? How do you decide what needs to be worked on first, or at a specific meeting even? How do you decide what's going to be worked on that day, or what is most important to be working on? So I'll go to Alex first.
So we determine our priority list at the very beginning when we're figuring out our what's in our hows. That's one of the first things that we talk about is we talk about every method to score, and then we determine how much we need to focus on it. So obviously things that are low scoring usually have lower priority. And sometimes one subsystem can have multiple ways to score too. So that factors into what we decide to forward with that subsystem.
Great. And then Zach, do you have any insight on that for 1678?
Sorry, can I actually direct this one over to Nathan too?
Yeah, for sure.
You take this one, Zach. You take this one. Unless you really want me to take it.
Yeah, sorry, can you take it?
Yeah, what was the question?
The question was, how do you prioritize what mechanisms your team needs to be focusing on first? Or what in terms of the span of build season, what needs to be worked on starting week 2, and what can be left for a little later in the season?
Right. Okay. So we always on 1678 we try to have our drivetrain done immediately within the first week, and so that really allows for some clarity, right? We get that done and we can build off of that. We don't have to be worrying about what we're going to mount things to. We have our drivetrain kind of figured out right away. Historically, we've always gone with West Coast. That's what we're going with this year. That's bound to change at some point, but it hasn't yet. So we knew we were either doing Swerve or a West Coast drive this year. And as soon as we saw the game, we were like, okay, we're probably going to do a turret. So let's just go with West Coast drive. And it was a super simple drivetrain. We used West Coast products, gearboxes, just super easy design. And we were able to have that right out of the way. And that really allows us to focus on the more complex mechanisms that go on top of the drivetrain. And so it really starts with, you have to figure out which mechanisms are going to kind of define what's around them, right? And so in our case this year, it was the turret and our indexer, right? Everything has to kind of fit around those. And so after the drivetrain, really the first mechanism that I started getting designed was the turret and the indexer. We could leave the shooter out for now because we know we're going to have space above our turret for the shooter later, so we can start that a little later. We know we're going to have the space on top for the climber that folds up. So as long as we know how it's going to look, we can start with the more central items and kind of figure out how everything is going to fit around it afterwards. If that makes sense.
As an example of that, I guess too, off of our Wheel of Doom, off of our indexer, and off of that turret, and the climber structure, just how that kind of defined everything on the robot, made it so that we ended up really working our intake, the dimensions of the intake and how that would fold up around everything else. We worked the control panel mechanism to be something that would have to, its dimensions work off of those dimensions. So I guess that's just one more thing on prioritization.
And then Lydia?
What we do is very similar to what other people have said. But another thing that we really like to focus on when we're doing our priorities, in addition to point scoring and stuff, is how we can integrate subsystems into each other. A really good example of this is our 2019 robot. In 2019, we were actually able to combine our mechanism for picking up both balls and the cargo hatches that were used in the 2019 game. We actually used a vacuum system for both, and they were both on the same mechanism for lifting, and then also our climb and our intake of those cargo balls both used the same mechanism arm to lift ourselves onto the platform in the 2019 game. And so by seeing what priorities we have, then we were able to realize, oh, hey, these things that we are trying to make sure that we have, they still have the same function, and these already existing ideas can go off of what we've already decided that we needed and been able to actually create a space saver. So then we're still able to do everything that we want to do without having to sacrifice other things that we want to do by integration.
Very interesting. Thank you, guys. It looks like we have time for one more question, just really quick. So the last question is going to be, what is the transition on your team from prototyping to CAD look like? For example, do you usually have the same person leading the prototyping as you have working on the CAD for each mechanism, or are they separate people, and how do they communicate what needs to be happening for that mechanism? So I think I'll go to Zach first for this one.
Yeah, we, for the most part, we try to have our core designers be prototyping leads. We have these prototyping groups figured out like a little bit before build season. And we make sure that our core designers are prototyping leads of whichever group they're in, just to make it a little bit easier so that there's less needed communication in transferring over that prototype into CAD. But then since we don't have as many core designers as prototyping groups, then we'll also throw in additional designers or fabrication members or even electrical members as the leads to the rest of those groups. For example, this year we had a fabrication student was the prototyping lead of our control panel mechanism, and then he handed that off to one of our designers, and she worked on that for the rest of the build season. And so, yeah, it's mostly just strong communication between those two in the teams that aren't that don't have the core designer being a prototyping lead.
Also, on the communication side of that, we try to be really organized about how we record tests and versions of each prototype, right? So we have maybe a document per prototype, and we just, we'll this year we tried to do like a kind of like a diary entry sort of thing where we would write down the date, what changed, what did we try, include some pictures, maybe take a tape measure, take some pictures of where, if we're working on an intake, right, we take some pictures of the dimensions of the placements of the rollers. So it's that sort of thing that really helps down the line when you're trying to transfer all of this stuff into CAD.
Okay, thank you everyone very much. I think we're pretty much out of time for this panel. Thank you to all the panelists and all the people who have been listening. So I think we're about done. Thank you very much.